Hi friends, welcome to Simplify Maths. Today we are going to learn Understanding Quadrilaterals, Chapter 3, Exercise 3.1 for Class 8, NCERT book. First question. Given here are some figures. See the figures carefully. Classify each of them on the basis of the following. Look at the figure 1. See this. So it belongs to which category of these curves? So is it a simple curve? Yeah, it is a simple curve because no intersection happened. Is it a simple closed curve? Yes, it is a simple closed curve because the starting and the ending point are same. So it is a simple closed curve. Next, is it a polygon? Yes, it is a polygon because it is a simple closed curve made up of only line segment. So it is also a polygon. Is it a convex polygon? No, it is not a convex polygon because one of the angle is greater than 180 degree, also a diagonal lie out exterior of the polygon. So it is not a convex polygon, but it is a concave polygon because one of the angle greater than 180 degree and the diagonal lies exterior of the polygon. Next, see this figure. It's a kite-like figure, right? So we will see what are all the types of curves it belongs to. First, it is a simple curve. Yeah, it's a simple curve because no intersection. It is also a simple closed curve because starts and ends at the same point. So it's a simple closed curve, right? Polygon. It is a polygon because it is a simple closed curve made up of only line segments. It is a convex polygon. Of course, it is a convex polygon. See, all the interior angles formed are less than 180 degree. Also, diagonal, all the diagonals lies interior of the polygon, no exterior. So it's a convex polygon. So it is not a concave polygon. This one, concentric circle, two circles. Is it a simple closed curve? No, it is not a simple closed curve. See, for tracing this figure, we need to lift our pencil and need to do the other circle, right? So it is not a simple curve. This is not a simple closed curve also. See, simple curve or simple closed curve. At a stretch we need to draw. We should not. If this is a circle, at a stretch we can draw. But for drawing another circle, we need to lift our pencil and again we need to draw. So this is not a simple or simple closed curve. It is not a polygon too because it is not made up of line segments. Also, it is not a convex polygon. No angles formed here inside, right? So it is also not a concave polygon. No exterior diagonals, no diagonals for this circle shape. Star. This is also not a simple curve because intersection happened at so many points. So it is not a simple curve. It is not a simple closed curve also. Simple means no intersection should happen. So it happened here. So both the things ruled out. Is it a polygon? It is also not a polygon because again intersection happened, so it is not a polygon. Even though it is made up of only line segments, it is not a polygon. Since it is not a polygon, there is no question about convex or concave. Fifth one, is it a simple curve? Yeah, it is a simple curve. It is also a simple closed curve. Is it a polygon? No, it is not a polygon because there is no line segments. It is not made up of line segments. So it is not a polygon. It is not a convex polygon. It is not a concave polygon too. Is this a simple curve? Yeah, it is a simple curve. It is also a simple closed curve because starts and ends at the same point. But it is not a polygon. Since it is not a polygon, it is not made up of only line segments. So since it is not a polygon, it is not convex or concave polygon. Next. Is this a simple curve? Yeah, it is a simple curve. It is also a simple closed curve. But it is not a polygon. So, not convex and not concave though. Eighth one. Is this a simple curve? No, it is not a simple curve. It is also not a simple closed curve. Why it is not a simple curve and simple closed curve? Because simple curve means if this is the curve, that's it. This is simple. But from here, it again comes over here and again it is doing something and make a curve. So this is not a simple curve or simple closed curve. Also, it does not start and end at the same point. That is the main thing. Also, it is not a polygon. So it is not a convex and concave polygon. Second question, how many diagonals does each of the following have a convex quadrilateral? For that, for example, I have taken this rectangle. Okay, so how many diagonals it must have? See, diagonals always lie upon two non-consecutive vertices. So this is one diagonal and this is another diagonal. These two corners, right? This is one diagonal and this is another diagonal. Two diagonals. For this, two diagonal possible. A regular hexagon. Hexagon means 6 sides. So what are the how many diagonals possible for this? Two non-consecutive. Let us connect the two non-consecutive vertices. This is 1 and this is 2, 3, 4, 5, 6, 7, 8 and 9. So 9 diagonals possible for this regular hexagon. Now triangle. Triangle. Is there any diagonal possible for this triangle? No, because non-consecutive vertices are not here. These two are consecutive, these two are consecutive and these two are consecutive. For this, these two are consecutive. So there is no diagonal possible for a triangle. The answer is 0. Third question. What is the sum of the measures of the angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex? Make a non-convex quadrilateral and try. See, the sum of the measures, just we have learnt it in part 2 video, introduction video of understanding quadrilateral. The sum of the measures of the angles of a quadrilateral. That means interior angle of a quadrilateral is always equal to n minus 2 into 180 degree. Okay. So for quadrilateral, it has 4 sides, n minus 2 into 180 degree, which is equal to 4 minus 2 into 180 degree, which is equal to 2 into 180 degree. This equals 360 degree. So if you, this is a parallelogram. If you add all these interior angles, it will give you 360 degree. So for the quadrilateral, the sum of the angles, interior angles of a quadrilateral is always 360 degree. Next, make a non-convex quadrilateral and try. It is a concave quadrilateral. The angle sum of the interior angles of these non-convex quadrilateral will also give you 360 degree. If you add all the angles, it will give you, you should come up with 360 degree only. Try making a quadrilateral like this and give your answers in the comment section. Fourth question, examine the table. Each figure is divided into triangles and the sum of the angles deduced from that. See, this is the figure 1. So, sides, number of sides 3. Angle sum is 180 degree. Similarly, this is a quadrilateral. So, they have divided these quadrilateral into 2 and made 2 triangles. So, number of sides 4. 2 into 180 degree angle sum is equal to 4 minus 2 into 180 degree. That's why it is 2 into 180 degree. 5 sides, 3 into 180 degree. How many triangles they made? 1, 2, 3. So 3 into 180 degree. See, interior angle of every triangle is 180 degree. So number of triangles made using the number of sides, using the polygon. So how many? Depending upon that number of triangles into 180 degree gives you the interior angles of all the interior angles of the pentagon, hexagon, whatever. See, this is a hexagon. So how many triangles made? 1, 2, 3, 4. 4 into 180 degree. 4 180 degrees. So that will give you the angle sum of the polygon, right? Fourth question, what is the angle sum of a convex polygon with the number of sides? So the general formula is n minus 2 into 180 degree. Keep it in mind. That means number of triangles we made. Just we have seen from the table. This gives you the number of triangles we have made using the number of sides. So this this will give you 7 minus 2 into 180 degree, which is equal to 5 into 180 degree. So the answer is 900 degree. Next, for this 8 sides means octagon. So 8 minus 2 into 180 degree, which is equal to 6 into 180 degree. This gives us 1080 degree angle sum. Now decagon, that means 10 sides, 10 minus 2 into 180 degree. See, using 10 sides, we can make 8 triangles. So 8 into 180 degree gives us 1440 degree angle sum. Next, n-gun. Here what comes? Here comes n minus 2 into 180 degree. It's a general formula. Fifth question. What is a regular polygon? A regular polygon is a polygon which is equiangular and equilateral. Equiangular means all the angles formed inside the polygon must be same, equal. Also, all the sides of the polygon must be equal. Equal sides, equal angles. So that is called regular polygon. State the name of the regular polygon of 3 sides. 3 equal sides and 3 equal angle means it must be an equilateral triangle. 4 sides, 4 equal sides and 4 equal angle means it must be a square. 6 sides and 6 equal angles means it must be a regular hexagon. Sixth question. Find the angle measure x in the following figures. See, it is a quadrilateral, right? It is a quadrilateral. So we are going to find the value of x, this angle. Always the angle sum of a quadrilateral is 360 degree, right? All the angles. If you sum up all the angles, it will give you 360 degree. So just add all the angles and equate it with 360 degree. So this will give you x equal to 360 degree minus, see, 250 plus 50, 300. So minus 300 degree, x equal to 60 degree is the answer. If you sum up all the angles and we can find and equate it with the 360 degree, we can find the unknown angle. Next, B. See here, 70 degree, 60 degree, we don't know this angle. So this is 90 degree angle and this is x. So shall we calculate this? X plus 70 degree plus 60 degree plus 90 degree equal to 360 degree. X equal to 360 degree minus 220 degree. X equal to 140 degree. See, this is a pentagon. 1, 2, 3, 4, 5. 5 sides are there, right? So now we will calculate, we need to find the value of this x. Both are equal also. So see here they have given the value of this angle. So this must be 180 degree minus, this forms a linear pair, right? Linear pair as straight line, and a line standing on this straight line means this whole angle must be 180 degree. So 180 degree minus 70 degree will give you this angle alone. So what is this angle? 180 degree minus 70 degree is 110 degree. This is 110 degree. This is 60 degree. So the remaining angle 180 minus 60 degree will give you 120 degree. So we have found out these two angles. So what is the value of the pentagon? For 5-sided pentagon, pentagon means 5 sides, right? So for 5 sides, what is the angle sum? What is the formula? N minus 2 into 180 degree. So this is 5 minus 2 into 180 degree equal to 3 into 180 degree, which is equal to 540 degree. Now we have all the angles other than these two angles. So we will add all these angles and equate it with 540 degree, because anyways the angle sum is 540. So we will add all this, right? So what are they? 30, 110, 120 and 2x. See, 30 degree, 110 degree, 120 degree plus 2x equal to 540 degree. Now we are going to calculate this. Okay. So how many? 120, 230, 260, right? So 2x, keep the x here only, equal to 540 degree minus 260 degree. 2x equal to, this gives us 280 degree. X is equal to 280 degree divided by 2, which is equal to 140 degree. So the value of x here and here, these two angles are 140 degree, 140 degree. Okay. D subdivision, this is a pentagon, right? All the angles, it is a regular pentagon. All the angles must be equal. So just we have seen for the 5 sides, for a figure which is having 5 sides, the angle sum equal to 540 degree. So the angle sum of all these angle gives us 5x, right? 5x equal to 540 degree. X equal to 540 divided by 5, which is equal to 1 time 0.8, 108 degree. If we cancel this, 108 degree is the answer. Each 108 degree each x must have. 7th question. See this. There is a figure with the interior and exterior angles. Now we are going to find the exterior angle values x, y and z, and we are going to deduce this addition. Okay, deduce this sum. Let's find out. It's very easy. See, this is a linear pair. That means linear pair means just to have it in mind as straight line, and if another straight line stands on this line, the angle next angle is called adjacent angle. These form a linear pair, but that means these two angles, if it is A, if it is B, then angle A plus angle B must be equal to 180 degree. So have it in mind. Next angle. See, this is a linear pair. Here forms a linear pair. See here, this is a straight line and this is another straight line. So 30 degree plus Z equal to 180 degree. So angle Z is equal to 180 degree minus 30 degree is 150 degree. Correct? So this is 150 degree. Next, 90 degree. So 180 for this, how to calculate? X plus 90 degree equal to 180 degree. This is also a linear pair, straight line and another straight line on this. So x equal to 180 degree minus 90 degree gives us 90 degree. So this is 90 degree. Now what is the value of this? For a triangle, the interior angle must be equal to 180 degree. So this angle must be 180 degree minus 90 degree minus 30 degree, right? See, all the interior angle equal to 180 degree. So this angle is equal to 180 degree minus 90 degree minus 30 degree. That means addition of these two angles. So 180 degree minus 120 degree, which is equal to 60 degree. If this is 60 degree, what is this y? Y is nothing but y plus 60 degree is equal to 180 degree. Linear pair, straight line and another straight line on this. So y is equal to, angle y is equal to 180 degree minus 60 degree is 120 degree. The value of this y is 120 degree. So what is the addition of these things? X is 90 degree plus y is 120 degree plus z is 150 degree. It sums up to 200, 250, 270, 270 plus 90 is 360 degree. So sum of the exterior angles is 360 degree for this figure. Next, here also we are going to calculate the sum of the exterior angles. First, for that we need to find the value of x, y, z and w. So let's do this. for Z. How to do Z? Linear pair, right? So Z angle equal to plus 60 degree equal to 180 degree. So angle Z equal to 180 degree minus the 60 degree is 120 degree. So this is 120 degree. Now Y. Y is equal to, angle Y equal to 180 degree minus 80 degree, which is equal to 100 degree. So this is 100. X value. This is a linear pair again, right? So angle X equal to 180 degree minus its adjacent is 120 degree. This gives us 60 degree. So this is 60 degree. Now W. See, sum of the interior angle of the quadrilateral. Quadrilateral means four-sided figure is always 360 degree. So if you add all this and equate it with 360 degree, we will find this value. A plus 60 degree plus 80 degree plus 120 degree equal to 360 degree. Correct? A is equal to 360 degree minus 120, 200, 260 degree. So A is equal to 100 degree. So this value is 100 degree. If this is 100, it must be 80 degree. 180 minus 100 is 80 degree, right? Now we are going to find what is X plus Y plus Z plus W. What is X? 60 degree. What is Y? 100. Z is 120 degree and W is 80 degree. So this is 160, right? 160, 260, 280, 280 plus 80 is 360 degree. So always the angle sum of the exterior angle are always 360 degree. So with this, understanding quadrilaterals exercise 3.1 got over. If you like this video, do subscribe our channel. I'll meet you in my next video, understanding quadrilateral chapter 3 exercise 3.2 for class 8. Thank you.